Hello, everybody. It's Mrs. Pound, and we are talking about weather in chapter 5.2. So, the first thing we need to talk about with weather is heat transfer because we're going to discover that a lot of what happens with our weather has to do with heat. So, our objectives today are to compare the methods of heat transfer, correlate the Earth's seasons to its orbit, and infer how a thermometer measures temperature. So heat. Heat is the transfer of energy from one substance to another. If there is no transfer of energy, there is no heat. The reason you feel heat from this wood is because there's a transfer of energy from the burning wood to your hand. Now, if your hands feel cold, like if you were to touch ice, there's actually heat there too, except for now there's a transfer of energy from your hands to the ice. So the heat flow is the other way. Now, there are different ways to transfer heat, and the first way is radiation. This is the transfer of energy through space by electromagnetic waves, and an example is the sun. The heat that we receive the sun must go through space. We are not directly touching the sun or anything like that. It has to travel through space. This also is how you get heat from that fire. Okay, you don't hold your hands right on the fire, you hold it back because there is radiation, there are electromagnetic waves, actually infrared, that go from the fire to your hands. There's also conduction. This is the transfer of heat from one substance to another substance through direct contact. And some examples are an ice pack and a hot spoon. Also, I have on the burner there a pan. Now, as far as the pan is concerned, it can get radiation heat from the flame underneath. It does not necessarily have to touch the flame, so that would be radiation. But the contents of the pan, that radiation will heat up that copper pan or whatever metal it is made of. Copper is a really good conductor of heat, so that's why it's commonly used for pans. Also, steel and aluminum are as well. But the water that's in that pan will be heated up through conduction because it is directly touching the pan. And then if you were to touch the handle of the hot pan, you would be heated or burned actually through conduction. Also, you would notice that after a while, if you stuck a spoon in the water that's boiling in that pan, that the end of the spoon would get hot. Again, conduction, because everything is touching, it's direct contact. There's also convection. This is the transfer of heat that occurs in moving fluids, liquids, or gases that is caused by the circulation of currents from one region to another. And this is what happens with convection currents in the atmosphere that we're going to talk about. We also talked about convection currents within the earth, in the mantle, that causes tectonic plates to move. So we have convection currents happening in many places. In and on the earth. And so this is what I have a windsock here because that's what causes our winds. You will have um, air being warmed so it will rise, and then it will fall when it cools, and you get this convection current going on, and that is what causes our winds. Now, the Earth's seasons. Let's talk about these for a minute. We're going to talk about them in another chapter as well, so I'm not going to go real into depth on this. But the Earth's seasons are caused by the tilt of the Earth. It's tilted at 23.5 degrees. The tilt creates different intensities of radiation or light energy from the sun, which causes different seasons. So let's take a look at this diagram. So here's the sun in the middle. Now, let's take a look at summer when it is June. It is summer in the northern hemisphere. It's winter actually in the southern hemisphere. So if we look at the rays are hitting with intensity right here above the equator. They're more intense in the northern hemisphere than in the southern hemisphere. That's why it is summer here and winter there. In December, we can see that the northern hemisphere is tilted away from the sun, the southern hemisphere is tilted towards the sun. So now it's summer in the southern hemisphere, winter in the northern hemisphere. The intensity of the rays is below the equator. And so that's why it is winter for us because there's less intensity. Now, at the equinoxes, the intensity of the sun's rays, it's most intense at the equators. And so that's why we have kind of moderate temperatures there in the spring and the fall, in between the extremes of summer and winter, because of where the most intense rays of the sun are hitting. They're more at the equator. And finally, temperature is always involved with heat. This is the measure of energy in the molecules of a substance. And as far as heat flow is concerned, heat flows from a higher temperature to a lower temperature. Okay. When things are the same temperature, there is no heat flow at all, no heat flow. And also with a thermometer, what is happening there? Here I have a liquid thermometer in the background. And what happens there is that if we put this in, say, boiling water, the thermometer in boiling water, the liquid will go up the thermometer because heat energy will be transferred from the water to the thermometer, causing the molecules to spread apart, start moving faster and spread apart. And so the liquid in the thermometer rises. Now, if it was put in ice water, what would happen is the thermometer would be warmer than the water, so energy would leave. As energy leaves, the molecules in the liquid slow down, they come closer together, and they go down in the liquid. So that's how a thermometer, a liquid thermometer, works. And that will happen until there's no energy transfer, and that's when we read the temperature. So when they reach an equilibrium, that's when it stops and there's no longer any heat transfer. Now, there are other kinds of thermometers that we use as well. Scientists will use what's called a bimetal thermometer, which it has two metals on it that contract and expand at different rates, and so they will actually bend. And so when it gets hot, the metal will bend, and when it gets colder, it will straighten. And so they're able to figure out the temperature that way. There are also thermometers that are used that are based upon the conduction of electricity. And electricity will conduct at different rates at different temperatures, and they're able to measure that in the metal. And the conduction and the bimetal thermometers tend to be faster and a little more accurate than the liquid thermometers. So scientists will use them for that reason because they are a lot faster, especially. Now, if you are listening to this video, show me that you are listening by writing next to, or actually drawing next to temperature, a thermometer. So draw a little thermometer. Okay, so our objectives today were to compare the methods of heat transfer, to correlate the Earth's seasons to its orbit, and infer how a thermometer measures temperature. Don't forget your 5 questions, and I will be back with a lot more about weather. This is a pretty long chapter.